Hello students. So in the last lecture we have discussed the basic or introduction to T-beams. In this lecture we will cover the remaining portion of the introduction to T-beams, and also these two lectures, that was the previous one and this one, will be very beneficial in your solving numericals later on. So refer both these videos properly because it contains all the equations and basic knowledge about how to substitute values and how to look upon RIS code. So taking a brief lookup of what we have discussed in the previous lecture, we have seen this stress strain diagram of T-beam. Here generally we have discussed about various forces. For example, C1 and C2 were our major concern. C1 was the compression force due to our singly section, and C2 was the compression force due to the hedge portion that we have seen, or the slab or flange portion. The value of C1 was 0.36 FCK BXU and the value of C2 was 0.446 FCK BF minus BW into DF. Now this 0.446 FCK is the stress component and BF minus BW into DF is the area. So multiplying stress into area, we always get the force. T being our tension force was obtained as 0.87 FIAS. T, Z1 and Z2 were the lever arm. Now today we will be discussing these two forces, that is FC and FT, about how to find this FT and FC, because it contains a majority of portion in your solving the numericals, because the first step of numerical in every case will be to find this value, that is to find FC and FT. Now again, looking at this section, we need to find the value of XU. Keep in mind, in the codal provisions we have, or we need to derive the relation between XU, but directly we won't be able to find XU. So how to relate this XU? Now as we have already seen, XU is the depth of neutral axis. So the neutral axis is, the depth of neutral axis always starts from the top portion. So here we can say that the neutral axis will be from top of slab. So the neutral axis can be here in three cases. The first case will be neutral axis can be in this zone, that is our flange portion. Neutral axis can be in this zone, that is our junction, or the plane between flange and beam, or the plane between our the slab portion and beam portion, that is our web portion. And third case will be neutral axis can be in this layer or this zone. Clear? This is our web. So three cases we need to refer. We will be seeing these three cases in deep. First, let us assume that neutral axis is in this zone, that is neutral axis is in flange. So if neutral axis is in flange, this distance will be over XU. This distance will be over XU, but as we all know that this distance will be DF, that is depth of flange or thickness of slab. So in this case we can compare these two cases or these two terms, that is XU and DF. So whenever neutral axis is in flange, we can relate that XU is always less than DF. Clear? From this figure, whenever neutral axis is in flange, we can always relate that XU is less than DF. This will be very helpful by solving the numericals, because the first step will be to identify where is the neutral axis. So again, for flange or to neutral axis to be in flange, XU should be less than DF, or vice versa, that for XU less than DF, neutral axis should be in flange. The second condition will be that neutral axis is in this zone. Clear? Now if we take neutral axis in this zone, that means this distance will be considered now as XU, and we all know that this is also the DF, or the value of depth of flange. So in this case XU will be equal to DF. This case XU will be equal to DF, that is our balanced or limiting value. So whenever neutral axis is in junction, XU will be equal to DF. And the third case, we'll be moving forward to the third case. For third case, our neutral axis can be in web. So in this case, this distance will be our XU. DF remains the same because it is the thickness of slab. So for neutral axis to be in web zone, XU will be greater than DF. These three relations we need to find, or we need to remember. Why so? Because XU value cannot be obtained from our IS code. To relate that, we will be relating these two terms, that is FC and FT. To find XU, we always will be referring, or the first step of our numerical will be to find FC and FT. F stands for force and C stands for compression, whereas T stands for tension. Now how to find this? For this, we need to assume that neutral axis is in this zone, that is our junction. We are assuming that neutral axis is in this zone, that is our junction. Now FC and FT. For FC, that means compression zone. So if this is our neutral axis, this zone will be our compression zone, the entire slab portion, and the bottom portion, that is web portion, will be our tension zone. So it will be easy to rectify two rectangle portions. So for simplicity only, we have assumed that the neutral axis is in junction. We can take any of the three cases, but only for simplicity, to get a proper rectangle, we have taken that neutral axis is in junction. So now how to find this value FC? As we have already seen, FC, that is force, clear, or force due to compression, and compressive force is always equal to stress into area. Now this area, this distance is our BF and this distance is our DF. So the stress here will be 0.36 FCK BF DF. So the stress value of the, or the compression force value, FC, will be always equal to 0.36 FCK. That is our stress. This value 0.36 FCK is our stress, and BF into DF is our area. Clear? And FT, that is our tension force, will always be equal to 0.87 FYAST. So to find the location of neutral axis, we always need to find these two values, that is FC and FT. Now how to relate this term and to find our condition, that is neutral axis. So for that case, as we have already calculated FC and FT, that will be three cases. The first case will be that FC could be greater than FT. The second case could be FC is equal to FT. And the third case could be FC is less than FT. Now in the subject mechanics of solids, we have already seen that if the force is greater, CG will be shifted to that zone. Again, if the force is greater, CG will be shifted to that zone. For example, if FC is greater than FT, that means compression force is greater than tension force. So whichever force is greater, the CG or neutral axis will be shifted to that zone. So if we get a value FC greater than FT, then neutral axis will be in flange. Clear? So neutral axis will be in flange. If we get relation FC equal to FT, that means both forces are same. So for that case, neutral axis will be in junction. And if we get value FC less than FT, that means FT, that is tension force, greater than compression force, then neutral axis will be in web. These are the three cases that we need to remember to solve our equation, that is these three cases. For FC greater than FT, neutral axis in flange, we have seen that via diagram. Second will be FC equal to FT, that is neutral axis will be at junction. And third case will be FC less than FT or FT greater than FC. So for this case, neutral axis will be in web. Now why to find these three cases? Because we need to find the equation of XU, and for this case you need to pause this video and move on to page number 96 of your IS code. If you go to page 96, you will see this case. Till now we were discussing clause G1.1 and G1.2. From now onwards we will be referring clause G2, that is our flange section or T-beam. And here you can see it is mentioned G2.1 that for XU less than DF. We have seen in previous slide. If you have missed it, go back to the portion and refer it again because it is our important topic. So the first case is being given as XU less than DF, and XU less than DF, that means neutral axis is in flange. So to find this case, or whether it will be implication of, or whether we need to imply G2.1, G2.2 or 2.3, we will be finding these three relations. That means we need to first find the location of neutral axis. If we get the location of neutral axis, then we will be able to see from the code that whether we need to use equation 2.1 or 2.2 or 2.3. Yeah. So again, for every numerical, our first step will be to find FC and FT. We will be getting any of these three cases. From that case, we can identify the location of neutral axis, and from the location of neutral axis, we will be seeing which equation to use. So the first equation, that is G2.1, it is mentioned that for XU less than DF, that means neutral axis is in our flange. So for that case, it is mentioned the moment of resistance may be calculated from equation given in G1.1. You can see in your IS code G1.1, that means singly section. So whenever XU is less than DF, the answer will be solved from the singly section that we have already seen. We will see numericals from the next video. So for second case, that is G2.2, it is mentioned the limiting value, and limiting value, that means balance section, and balance section, that means always the two forces are equal, that is FC equal to FT. So for FC equal to FT, we will be using G2.2. We'll go in deep while we will be solving the equations. And for third case, that is this is given in your page 96 and this equation is on your page 97 on your back side. So G2.3, here you can see that for XU max greater than XU greater than DF, that means for XU greater than DF. So for XU greater than DF, that means neutral axis is in web. So if we get answer neutral axis is in web, we will be using this G2.3. So again, taking a summary of this thing, first we need to find FC and FT. If we get FC greater than FT, that means neutral axis is in flange, and we will be using G2.1. Clear? Second, if we get answer FC equal to FT, then neutral axis is in junction, and we will be using 2.2. If we get answer FC less than FT, then neutral axis is in web, and we will be using 2.3. Okay? So these are the basic equations that we will be going through while solving numericals from the next lecture. So we will see in the next lecture. Thank you.